We'll just introduce you here. So our next speaker for the 1:45 p.m. slot is Dr. Kenneth Tram. He's a program manager with Modern Geosciences with over 25 years of experience working daily on a variety of projects concerning air quality, environmental due diligence, risk-based closures, and remedial strategies. He served as a national environmental practice leader for 2 large engineering firms prior to founding Modern Geosciences in 2011. He holds a master's and doctorate degrees in environmental science and engineering from the University of Texas at Arlington, and a bachelor's in bioenvironmental sciences from Texas A&M University. Yeah, I think we're recording on this stuff. Yep. He's a licensed professional geoscientist in Texas and Louisiana, a certified hazardous materials manager, and an adjunct professor with UTA's Geoscience Department. Dr. Tram is also the author of Environmental Due Diligence, a professional handbook, and currently serves on boards within the University of Texas and A&M Systems. And he's also served as a subject matter expert on behalf of the Texas Board of Professional Geoscientists. Dr. Tram, welcome.
Okie dokie. Well, thank you for being here today or watching at home, whichever one you're doing.
I'm going to move over here.
Okay. All right, because I'm clear now. All right, I'm going to start pushing buttons. It could all go wrong quickly. All right, so I'm going to focus on the controller. Yeah, I'm back in. Okay, I am an Aggie, as you said, so anything can happen up there. All right, so in putting this together, I thought it was good to discuss a little bit about a specific area that kind of this benchmarking comes from, which is the Barnett Shale, which has had, some national attention. Some it didn't want, but nonetheless, there it is. It's kind of a conflict between, a really rich and productive area, energy-wise, and a lot of growth at the same time. And so some misinformation abounds in some of that still to this day. That led to some municipal programs. We'll talk about that. And then it gave us some data sets. From that data set, we can make some benchmarking comparisons. So this gives you the footprint for that Barnett Shale area. In general, you're looking at North Texas, right? So think of the DFW area, but take out the D, right? So let's move over a little bit further west and a little bit south, and you're sitting on top of a unit that was known about for a long time until the technological advances came along to say now we can maximize production out of it. So some of that being in the 90s with Mitchell Energy, probably were others. These are the ones that I know about. The core counties, if you will, would be Denton, which is kind of in the hot spot centerpiece of it. Wise, I'd say next, and then you move to Tarrant and Johnson, and I'll show those in just a second. But essentially, late 90s, but really 2003 to 2011 was the heyday of seeing a lot of growth in that area. This is a well-known and presented, if you haven't seen it before, it's interesting, right? So the black dots are your traditional, just vertical. And then the red dots, which show up in just a moment, you can see people starting to do unconventional shale gas. I'm not sure we can call it that anymore because there's so many of them. How's it unconventional anymore? But down on the bottom left, you can see the production elements of it. But you can see we quickly expand to these other counties. So we were feeling it in Wise County for sure, and in Denton County. It expanded quickly. Some of these towns that they are in, or cities, are very small, and they've got a lot of changes ahead as they move to redevelopment in these areas and the wells come out, right? There's sensitivity to that too. So living in that, meanwhile, we had, this happening. So this is kind of the tail end as we look at 2010, but it was a similar growth pattern. We just look to where the fastest growing cities, well, many of them are in those counties. So for the DFW area alone, I was just looking recently, I think between 2020, 2011, so we're still kind of in the pandemic piece of this. We were easily seeing over 250 people a day, right, coming, right? So just think of that for a minute. They got to go somewhere. So that's going to expand out into those areas that you saw, a lot of those red dots, right? So that led to concerns, people that were there previously, but these two confluences just meet and it brings people close together. A lot of oil and gas activities, I mean, right, the term wildcatter, right? I mean, all these, there's an attitude it takes to go out, make this happen. But out, make this happen comes with it. So there's some perception issues, and some of that led to, like I said, some stumbles along the way, perhaps, that people would do differently. So just to hit some of those highlights, 2008, we see a town that became known as the town of Dish. I don't actually remember its name before it was the town of Dish, but I think they sold the rights to the name of the town so they could get free cable. Right? You remember Dish Cable? That actually is true. Isn't that the strangest thing? I hope they still get it. Who knows? But they're Dish today. So Flower Mound, Fort Worth, these were some areas that a lot of people were, buying fancy homes, larger footprints. And so they had expectations when they move out to the country, but that coincided with some of this. So that led to them asking questions, taking samples. I will say some samples collected correctly, some samples collected incorrectly, and then looking at that data and what did it mean. And the regulatory agency at the time didn't have criteria for some of this. Texas later comes out with what's known as air monitoring comparison values. Did not exist before, but it has probably one of the widest sets in the U.S. today, and I see it cited in Colorado and Pennsylvania. So these AMCVs become important, but they did not exist until people started taking samples. And then they're like, all right, quit comparing it to that. That's for modeling. Quit comparing it to that. Right. So we had to. That's pain. Growth is pain. That's what happened here. 2009, TCEQ does a pretty interesting study, big for its time, where it looks at 180 wells, give or take, and they actually go to the leak. So like, what's going on right here? Right, what's coming out? From that, they do identify some elevated benzene in a certain percentage, not in all of them, but it means it can happen, and it wasn't at least anticipated to be a part of the mixture, right? So we're in an area where it's primarily methane. Right? I mean, almost connected, put it on your stove and cook a cheeseburger. But there are portions of it that have different mixes, and even a little bit of other can make problems at your fence line. So that study was done. There's some carbon disulfide stories that are in there and some other things I won't get into, which are more stumbles in just understanding toxicology. 2011, the city of Fort Worth decides to step up and say, we're going to be very specific about us, but we've got a lot of wells. We're hearing with a lot of those dots, and we are an energy-centric city. That's me speaking for them, but I do know them well. I even visited on some of the scoping that ended up being in the study. But so a large scale, and also I'll call it a compliance study more than anything else, which is to say, are these people complying with the rules that are on them? In between compliance and public expectations, sometimes there's a gap between those two, and so some other data filling those spaces could be helpful. But the end result was they began with going out with optical gas imaging equipment, finding those leaks. Let's take samples of those leaks. Let's know about what's in them. As the quote has in here, they quickly found so many they couldn't do it. Right, so there's that many leaks occurring. Right, unintended emissions, fugitive emissions, if you want. So they kind of scaled back and they said, all right, well, at 164, we're going to stop. And so 164 samples were collected. That's a lot of data also. They didn't evaluate norm and a few other things which have become more traditional. There's mentions of air quality, but it was done in such a non-investigation design kind of way. It doesn't answer that question to most people that kind of get into the weeds, but it did find actually an elevated amount of methane in quite a few samples. That's interesting to me without the other data that goes with it. From that data, if we took those samples, because I like mining this data, if we can just understand where we've been, it'll give us a little more information where we might be going. Right, so if we look at those samples from 2011, 50 of those, 164, so roughly 30%, had elevated benzene. So let's use 1 ppm as our number for at least to make a cut, because it gave us 34. So those are presented up here, right? So the benzenes in parts per million by volume, and the methane seen in that same sample set is over here on the left side. Okay, so benzene's in red and methane's in blue. And I just wanted to see, is there a correlation, some connectivity? And the answer is really no, right? There's none here. We've looked at it through other plots and other things we can do, but it's just not here. So the answer is you can't totally say that leak is a problem or not a problem. So that didn't help with the perception piece of the story. But it did tell you that fence line data is good to get. If you chop a little further into it and you look at the benzene, that was the highest. So let's move up to 10 ppm. Right, 13 of the 14 events. So not a big subset inside this group, but it's still a smaller group. Right there at the above ground storage tanks, which had kind of been neglected from the storyline. Industry folks would probably have told you early on, like, well, that's what I'd expect them to be. But so anyway, that's not kind of in the narrative of the report because it was meant to find how's compliance doing, and there's a lot of elements to compliance that then the public still gets wrapped around the axle because it's kind of a weed and a soup in itself. But that's just data from the event. So that's interesting to have. By 2014, we get this other thing happens at the city of Denton. Are you both familiar with this event? All right, so the citizens get together and they convince everybody that they can politically to ban it, which of course Texas is a mineral rights state to start with. So that wasn't going to end well. So for 196 days, right, it stood and people talked about it, but the take home is it was not going to stand for very long. So it was responded to in short order. House Bill 40 is commonly what that's referred to as the end response, which is like municipalities have certain rights, but maybe not to just shut this down for sure. Not even maybe, certainly not to shut this down for sure. Right, and so some things that came from that is, okay, what is commercially reasonable? What are expectations? What kind of things can the city at least ask for, obtain themselves perhaps? And so some of that was an inspection level, very surface, not subsurface, evaluation. Subsurface had other rule sets in the Railroad Commission that could be applied in certain settings. The TCQ then could be applied. But we look in that same year in 2015, we're 5 years into a program that Grand Prairie, right, another DFW city, put in place, which really was a leak detection compliance plan, pretty much saying, operators, you know your business. We'd like you to see that you have a plan. Please communicate what that plan is on how you look at leaks and communicate back to us what kind of compliance you have with your goals. And so it was a little open, and unfortunately the end result was many of them said they never had any leaks, which doesn't comport with, right, the other things you saw here. So again, kind of if we're going to communicate with the public, there should be an expectation of, well, they do happen, and we find them, and we fix them because we want to sell gas. So that led to 2 operators over a 5-year period never had a single leak, which is really impressive. We should find out what they were doing. Or we can snicker a little bit. But moreover, say maybe it's a definition thing, right? Things such as that. So one of the pad sites from one of those 2 major operators, big name, we asked the city, we can do, just an inspection like we do on, in other places and see how they're performing. So the city said, we like this one. That operator was notified and said, we'll have everything ship shape. You come out and we won't have leaks. We're good because we reported that way for 5 years. And so 16 leaks were found quickly. And the operator said, oh, well, and so repairs began on those 16, right? So it's just, again, not out of an intent to make leaks, but perhaps on a process understanding, maybe definition understanding. So later, I'll mention a very simplistic formula, right, on the leak rate, number of leaks divided by the number of wells. If we did it on that one pad site, we would have been a 1.45. So tuck that away for later. So anyway, it led to some updates in their guidance and expectations, as you might think, and hopefully better compliance. And we've seen some of that over the years. 2016, they finalized, I'll say that, but this has been back and forth, and does it apply, not apply? But Quad A came out as a process, right? So optical gas imaging has been being used, right, in 2011. It was part of the City of Fort Worth methodology. So the technology was not new, it was improving. But the process was now in a defined manner that the EPA put forward if you do this, right? So you have a path and you got a distance and you got certain days that it works and you got to be able to see certain concentrations and certain tech is approved. So that's super helpful. It also took off the definition of a leak, things that were operating normally, right? So low bleed equipment doing what it's supposed to do, operators that had to actually emit periodically for their function. That also is there. And it's set forth a schedule. That's been back and forth by administration to administration. I think it's still in a time period where it's under comment and review again. So we'll see. It actually is really helpful, and I think it's a good tool to use in your program. All right, 2017. After all these things have happened, a lot of municipalities are starting to feel that pressure of redevelopment. They're very interested in understanding infrastructure in their town. They know their infrastructure, where are my water lines, where are my sewer lines. But knowing about where the wells were will be important as redevelopment knocks on the door, and what was where, and does it present a concern or not a concern. There's a gap is probably the best way to say it, between some rules that govern almost everything else versus govern the oil and gas operations, right? So Railroad Commission, TCQ, to cite the state programs, the departments. So knowing enough to answer those questions when those rules change, right? Railroad Commission is there when the operator or spills and releases related to the operator are there, but after that period of time, there's a different expectation that the public has, where you're going to build my house and I'm going to live, perhaps, right? So being the middle person with that data is very helpful. So that led to post-production inspections, meaning, okay, this is either about to leave or has left. What can we know just to provide comfort, either from a municipal standpoint, a property owner standpoint, or right now I'm supposed to be on a conference call, but I said I can't make it, right? New developers that are coming in, they're saying, look, we have equity that's nervous because there's been oil and gas, and we understand they can do certain things that we can't do later. And so, right, making some guidance that bridges that with an understanding of those differences is helpful, right? Again, answer it with data. So, looking back at norm as one of those kind of PPI things, post-production things, they're one of those gaps that exist. In 2003, right, an attorney working for the Texas Radiation Advisory Board noticed that gap and referred to it lovingly, probably, as a trial attorney's dream come true, right? Because you can leave certain things, it's never documented in the deed nor with the owner, but if somebody else were to build on that, those numbers don't match, and it would be seen you're giving an excess risk on where somebody may turn residential, right? So it's just a gap in those elements. So some cities, for example, like in Fort Worth, you can't build over a gas well. It's got a 5-foot setback. It actually has a signage, although it's not funny, but it happens. In some other cities where we've seen them do the signage, the landowners have gone and cut off that sign just so they don't have it when they're trying to sell their property. So that's a municipal part. That's not a Railroad Commission part, right? Railroad Commission does not regulate that part of the development that comes after. All right. This actually was one where the development is probably shortly going to come closer to the pad site. And this is one where we saw, elevated norm readings, right? So if you go on the Railroad Commission's website, they actually did, a very limited study, but one to say, hey, what kind of norm do we expect out there, right? So when I say norm, naturally occurring radioactive material, typically you're looking for gamma because you're on the outside of, right, metal equipment. So, so this actually is a norm survey looking specifically for gamma, but in microrankings per hour, right? So 50 is the point where you got to label equipment, you got scaling, and we've got some things to do to fix it before we can recycle it. Doesn't in itself make an elevated risk, although it probably does lowercase e have an elevated risk. This one is led by these dying trees along the fence line. Probably there's a chloride release here and the trees seen the brunt of it, and there it is. But the tanks themselves are so elevated in norm that it actually has this impact before you get to what I would consider background or near background. So if you were to build something in this area, you at least need to communicate to them you're in an area where you're going to get a little more. I'm not sure your grilled cheese is going to be done faster than anybody else's, but definitely you're getting a little more gamma up there. Maybe it's like taking an extra flight a year. I don't know. Probably similar in risk wise. Another thing we learned along the way. So a few operators, and I'll say some that probably were less informed in what leak detection programs were on their own, right? If you think of it, when you enter into a play like this, you get the primary operator. Primary shows up, those above ground storage tanks are painted, they look great, the fence is great, things are operating great, and hopefully the well makes them, a good bit of money, right? So money's up here. Then as it declines in years, you may get a secondary operator, right? So they come in and they know how to be more efficient than the big guys so that there's room for them. Then later you'll end up probably with a tertiary, and I don't know if there's some that follow afterwards, but whoever's stuck when the music has stopped playing needs to address some of the concerns that are related. They become the operator. They've signed all the paperwork. Railroad Commission will look to them. This is their lease. So those guys are trying to, on a budget, make things happen. So some of those operators, I think, were not familiar with optical gas imaging. And so when the cities would say, hey, we're going to go out and do some stuff. So the one you see on the top is actually Pet Site 1. So it actually was high noon. And the ask was, we think our program is so great that we don't need the city to come out. Just believe that we tell you when there's no leaks and we're good. Then the city said, that's fine. We'll show up and you bring whoever you want to bring. We're going to bring who we want to bring. And then everybody kind of gets there, talks for a while. And then our crew was one of them. We bring out optical gas imaging and some other equipment. And then the crew, I think that's probably been hired. They bring out optical gas imaging equipment, and we all both find leaks and items. This one in particular, unfortunately, I think the well had blocked up and it was blowing so much pressure that it made a very large area around the above ground storage tank that was above the low explosive limit. They took immediate action, right? So this is not something they would have said, this is normal for us operating wise. But it demonstrated without words being needed why inspections work. And so from that point forward, that data helped the operator. So these inspections were done to inform the operator as much as any stakeholder who was nearby, because real concerns were real concerns. Other areas we found in other cities, so not anything to do with this one we were inspecting, but have become problematic are these subgrade leaks. So they're not near equipment, so they're often missed and not thought about. So you don't want to park over that, nor do you want to have any other equipment that could have a static concern or other issues, but they can be missed, right? And we found these off the pad sites, right? So think of pad sites that are remote to each other. So those are not part of the average inspection program. So just things to be mindful of. All right. Escape, good. All right, yes, all right. So anyway, if I think back to the City of Fort Worth study too, by the way, we put a leak rate on that, right, that'd be 1.17. So I'm just giving you some context as we kind of look at the different cities and what did they see when they began to inspect. So we took this 2009 to 2019 data set, and the take home was by the operators and the cities for sure, less localized impacts if you had less leaks, that makes sense. And then, less lost profit if you had less leaks. And if they were going to spend the money anyway with cities for it, there's a permit fee, we're going to be here this year, you're going to inspect us. How great to get data that's usable, right? And actually now is quantifiable. Am I doing on time? Have I blown it all? All right. My parents are from New York, so I probably talk too fast. It's hard to be a mixture of New York and an Aggie, I know. Right, so our guiding principle, as Yogi Berra said, as I mentioned the Northeast here, right, you can observe a lot just by looking. So we looked at those municipal programs. We wanted commonality in what their use of terms were, the methodology for the inspections, obviously. So, right, so using this Railroad Commission number of 50 microgram or microrankin per hour, right? That's the number where they have to label the equipment. So it's high enough that some regulatory action is happening. So, and it's a good threshold because there's a lot below and they stand out when they're above 50 in general. There's not really a risk basis behind that number. The number probably should be a little lower if you were going to do like just a hardcore long-term chronic risk. I am told from people that work within the agency that number actually comes from when a gamma scintillometer was walked around the Texas state capitol. And with the granite that's in there, this is the number they saw. I don't know if that's true or not. It's a clean number. It's actually used other places too. All right, so optical gas imaging for one. Some of them had fence line data, some did not. Some had fence line data for its proximity to a sensitive receptor, which makes sense. That way you can reduce the cost and take that data where it's needed. But all of them had either an equivalent to Quad OA, an initial performance, or optical gas imaging afterwards. So that gave us a good purpose there between that and the 50. So if we looked at that data set, you can see down here, right, that gives us 1, 2, 3, 4, 5 cities across. A lot of differences in the population size of one city versus the other, right? So that's to be expected, but also helpful in how the ordinances were also changed. And so we're just trying to see what kind of performance there was across the board there. 20 unique operators, so some changing hands during the event, were represented too. So near equipment inspection became a term that we put together, and that may be just what you think it is. We are near equipment. We're not very fancy. Right, so we are close enough that our optical gas imaging cameras will pick up these leaks, which I could click on them if you wanted to see them. And then we're close enough to mimic what would be done for a railroad commission inspection for norm, right? So you see a peg meter over here. We're recording other things such as, corrosion, things where it looks like there'd be a functional issue with, or even a ordinance compliance issue, but everything is done to scale, GIS, every major piece of infrastructure gets named, right? So everything can be tracked. Fence line stuff had a host of different equipment, but that wasn't part of our study, but it's interesting data to see when you have a leak, what does it mean elsewhere? And there's a few cases where we're called upon to do long-term monitoring, right? So to actually have contingency. You found this, you do this. Sometimes the fence line was if you found the leaks, we need to know what's going off site. And if it's going at numbers, then we need to set up points that monitor long-term, whether that was through thermally absorption-based methods with tubes, which you see down here, a gas chromatograph, PCMS look at who's there, to just different parameters, whether it be H2S, methane, et cetera. You're certainly not getting 30 ppb like someone can do here in the audience, or better. But that was helpful. So number of leaks, number of wells. Now, that's easier to work with than norm sometimes is, right? Because the number of wells, there's kind of an ancillary supporting requirement on site. There's going to be a separator, usually going to be an above ground storage tank. There may be a compressor. So those are all just lumped in together. So the entire pad site, and then divided by the number of wells. As you go to norm rate, right, so this is the number of norm occurrence. You can have long stretches of different pieces of equipment. So halfway between each major piece of equipment marks the break. So if I had a well and it was 10 feet to the separator, so from the well to the 5 feet, that's the well's number. And then here to the separator, that's the separator's number, right? And continue on. We needed a way to kind of verify that things fit together. So looking at a leak rate, real basic. If we went out and we found, looks like 1, 2, 3, 4, 5 leaks, 3 wells, that's how we get our 1.6. Right, so easy enough. So Flower Mound. So they had a decent data set for us. They had 8 individual operators over time. They actually looked at each well roughly twice annually, but it doesn't matter because each one is the event itself, right? Even if we went back to the same pad site the next day, that would be its own numbers. We wouldn't do that because they need to fix it, and we, wasn't the purpose of their inspection program at that time. But you can see there in red, we started with a higher leak rate, and you saw it decline in time. And then the norm rate, you see it slowly climb, which is not unusual, right? Because the operator doesn't have to go remove scale. There were some that took it upon themselves and said, oh, for the day when it comes, let's just go ahead and do good maintenance and sandblast the inside of the AST or the piece of equipment that had the problem and clean it up. And some, they probably were waiting to do it at the end of the day. But it's just an observation of what did we see more than anything else. So that was good for Flower Mound. Grand Prairie, we start from the first event in 2015, right? That was the example. Come on out. We want you to see what you see. From that original leak rate, going all the way down to what they currently see is roughly a 0.51 leak rate, which is not bad. Right? I'm going to follow that under, not bad. And then the norm rate slowly creeping up. So that meets expectations. For Denton, again, we started roughly about 0.8 across. They have a lot of wells across all their wells. So some 539 leaks, 859 individual well inspections, and ancillary equipment associated with 2,884. So a lot. But we see the leak rate, but we actually see the norm rate go down a little in the last bit too, right? So there's some operator performance happening in some of that, which is great to see. Coppell, which is a small, right, one pad site, right? So it's a good kind of other side of the coin for the Denton one. So we've seen the leak rate be down and low, but as a small pad site, right, the resolution is such that even small changes look big on here. So you have to understand the numbers and how they fit together too. Castle's kind of in the middle of that. And it had seen a peak in 2019. And I don't know if that means more gas wells were active. There was maybe a change in operators. There's something in that data. But since 2019, it has gone, they say about the same, but then it went down in 2021, which I know is not in this data set, but I was just very interested to see it. And so it's kind of coming on back, and norm continues to kind of just slowly climb, again, as expected. But in these reports, you would know which pieces of equipment had it, didn't have it. So even the operator could just flip back and go, okay, these are the ones we know we got to go take care of. So again, useful to hopefully everybody involved. All right, so take all of that data. Here's some specs about it, right? First year versus current year, right? So roughly a 50% decrease. If you look across all the numbers, law of large numbers, right? So you can cut it in half by having an inspection program. That's fantastic. The norm, right, almost grew by just a hair more. Not good nor bad, just information. But it's probably what I would expect, having worked in this for quite a while. If we take those data sets and we try to average them out, okay, a good functional program, the operators are responsive, leaks are found, they're repaired. You can see them operate usually at about 0.5 or less, and that's just good operating. You know, again, this is me just looking through the data and starting to get comfortable. What does the 0.5 mean? It means for every 2 wells, there's probably 1 leak on that site. That's doing pretty good. Versus, you know, a little worse and worse as you go, which if you had no inspection program and no one ever looked, you'd probably see 1.5 or higher, right? That's kind of what we found in the data set. And then the flip side of that is just operations with time. And, you know, in here is not a knowledge of how productive was that well, how much water did it make, all those elements. So law of large numbers, just throw them all in there together. You can kind of come away with a less than 0.4 for norm occurrence above that 50, and then up to 1.2 or higher. There's probably a lot of norm going to be here for somebody to clean up, and so it's on the higher end. So if we look into that data a little bit, none of this will be surprising to operators. Highest number of leaks, almost 50% at the separator. Right at the point that you're seeing changes in pressures, you're going to see things like this. AST next, and then probably about equal at the well or at the ancillary equipment that's operating the well. And then as we go to norm, by and large, the AST, right? The scales have been able to sit there. A temperature delta has probably helped in the process of the scaling that's going on. After that, the separator, then the well, and then very few times do we see it in the ancillary equipment that's supported, but we do sometimes find it. So if we did my example with the 5 and 3, right, we would have been sitting at 1.6. So we would have been like, we got room for improvement, guys. If we look at Flower Mound and look at their data set, so this is where they started in 2014 when they began a program. And then this is the last data set I have in here is 2020, but it's remained about the same. They're sitting at about 0.47, right? So pretty darn good. And if we stick in Flower Mound, right? So we'd find they had a little less norm, and now they got a little more norm, right? So par for the course. Expectations probably meets a common sense understanding, but it means there's probably going to be some management issues coming, and maybe a little more emphasis as you transition from the production phase to the post-production phase, where it may become homes or other operations. There'd be some questions to ask. Because we do find, unfortunately, where people like to bury norm-containing equipment, maybe leave that behind, and there's things happen. It's always the other operator. They did that. How did that get there? If we looked at the 2015, right, so this was Grand Prairie, operated for 5 years, had no leaks. And they said, sure, come on out and do your audit, because we know we're awesome. When we show up, we've got a leak rate of 1.45, like we talked about before. But today, 0.5. Again, part of it's education, part of it's just knowing. Like, it seems like no one's surprised, like people don't speed as much when the police officer is hanging about. You know, I suppose there's some of that. But I think some of it is honestly operators probably learning some of this themselves, maybe even independent of these questions being asked. We know several of the operators that we have done inspections on, they use those reports internally for metrics, right, to meet their demonstration criteria. So that's a big plus. That means we're doing something productive and useful. If you collect any data, I hope it's productive and useful. And this is a good example of not everywhere is collecting norm with time too, right? So that same pad site is either very well maintained, or perhaps, right, because I'm looking at one pad site here, not across the town. Maybe this is in an area that's super dry, and any of the fluid coming off just doesn't have a lot of scale building up. So you gotta have allowances for those kind of things. As far as what happens next with all the growth that's going on, I think you'll see increased scrutiny on pad site redevelopment, bridging that gap so people get comfortable putting their money down on the redevelopment option that follows, right? The oil and gas story is over, but they want to feel comfortable that there's not a heightened risk because of that use. And it's just going to take time and data to get people there. And then pad site inspections, I think you'll see people use the lessons learned from some of this and hopefully produce usable data on the operator side, usable data on the stakeholder side. And that way, maybe the benchmarking would be a good, useful tool of kind of setting some expectations and performance. So that said, you have survived my presentation. I appreciate it. Any questions for me?
When you find a leak that's actually emanating from the ground itself, what's the big deal? I mean, it's just a localized emission.
Sure.
Is it actually a pipe, or is it the well is ruptured? Or?